Good day, everyone. So today we will tackle about hypothesis testing. So what is hypothesis testing? It is a formal procedure for investigating our ideas about the world using statistics. It is most often used by scientists to test specific predictions called hypotheses that arise from theories. So when we say hypothesis testing, it is a way to check if your ideas about the world are likely to be true using evidence. So it's like a detective investigating a case, but with numbers and data. So, um, what is formal procedure? So when we say formal procedure, it is a structured process with specific steps that must be followed with to ensure reliable results, and then investigating our ideas. So it is used to explore and test your assumptions or beliefs about how things work, and um, it is used mathematical tools to analyze data and determine if the evidence supports your ideas. And also, it helps you verify if your prediction about what will happen are accurate. And it's often based on existing knowledge or theories, helping to refine or validate them. So we have here five main steps in hypothesis testing. So first is state your research hypothesis as a null hypothesis and alternate hypothesis. So when we say null hypothesis, ang iyang symbol is HO, and then the alternate hypothesis is HA or H1. And the second step is collect data. Collect data in a way designed to test the hypothesis. And then the third one is perform an appropriate statistical test. And then fourth is decide whether to reject or fail to reject your null hypothesis. And then the last one is present the findings in your results and discussion in section. So, what is the importance of hypothesis testing? So, um, the importance of hypothesis testing is validating theories. So, confirms or refutes scientific theories, and also making informed decisions. So, it guides us decisions in business, healthcare, and policy making. Also, ensuring reliability. So, provides a structured way to assess the credibility of claims and findings. So, and here in Philippines, hypothesis testing ma-apply siya in academia. So, researchers and universities use hypothesis testing to validate theories and contribute to knowledge in fields like medicine, engineering, and social science. It also applied in healthcare. So, medical professionals use hypothesis testing to evaluate the effectiveness of new treatments or interventions. Also, in business, companies use hypothesis testing to assess the impact of marketing campaigns, product launches, and other business strategies. And in government, government agencies use hypothesis testing to inform policy decisions related to public health, education, and the environment. So, first, let's discuss about the first step. State your research hypothesis as a null hypothesis and alternate hypothesis. So, what is state your null and alternate hypothesis? So after developing your initial research hypothesis or the prediction that you want to investigate, it is most it is important to restate it as a null and alternate hypothesis so that you can test it mathematically. So the alternate hypothesis is usually your initial hypothesis that predicts a relationship between variables. So when we say alternate hypothesis, there is a relationship between the variables. And then the null hypothesis is a prediction of no relationship between the variables. So meaning when we say null hypothesis, there is no relationship between the variables that you are interested in. So, um, s- we have example of null hypothesis and alternate hypothesis. So, sa null hypothesis, mean or average not taller than women. And our alternate hypothesis, in null hypothesis, there is no relationship between the variables. And in alternate hypothesis, men are on average taller than women. So meaning, when we see alternate hypothesis, there is a relationship between the variables, which is taller than women. So we have here other examples of our research hypothesis, which is we discusses about null hypothesis and alternate hypothesis. So we have here a first scenario. So you want to test if a new fertilizer increases plant growth. So of course, our research hypothesis is the new fertilizer increases plant growth. And our null hypothesis, so when we say null hypothesis, again, there is no relationship between the variables. So, the new fertilizer has no effect on plant growth. So, nakita ninyo ang difference? So, when we say null hypothesis, the new fertilizer has no effect on plant growth. And the alternate hypothesis is the new fertilizer increases plant growth. So meaning, the sentence here, there is a relationship between the variables, which is connected to the research hypothesis, which is there is a relationship between the variables. The second scenario is, you want to test if students who study longer get better grades. So our research hypothesis is students who study longer get better grades. And our null hypothesis, the amount of study time has no effect on grades. And there is no relationship between the variables. And our alternate hypothesis is students who study longer get better grades. So there is a relationship between the variables.
So now, let us proceed to step 2, where we collect data. For a statistical test to be valid, it is important to perform sampling and collect data in a way that is designed to test your hypothesis. If your data are not representative, then you cannot make statistical inferences about the population that you're interested in. So, here's a step 2. We gathered information or data we needed for our statistical test. For the test to be valid, the data must be collected properly, meaning it should truly represent the population we are studying. We use a process called sampling, which means selecting a proportion of population to study. But this sample must be representative, and if it's not, then the result of the test cannot be used to make conclusions about the whole population. So for our example, if we want to test whether men are taller than women, our sample must include an equal number of men and women and also cover different social and economic backgrounds, and lastly, the scope of our study. So let's say we want to test the difference in average height between men and women. To make this test fair and accurate, our sample should include an equal number of men and women. So dapat kini siya atong number nga atong sample size sa atong men o sa atong women dapat equal siya. Next is represent different socio-economic classes. Apil na siya dili ang different socio-economic classes because pwede na siya maka-affect sa height sa tuwang sample size or sa mga tao nga include sa ato ang test. Next is consider other cultural variables that might affect height, for example, nutrition, age, or location. And also, the scope of our study. Kung asa ta, sa isa ra ba ka country or sa from one country different from the other. So, muna siya ang need natin diri sa collect data. We have to gather data that is properly representing a whole population. Next is the subgroup. Perform a statistical test. There are a variety of statistical tests available. They are all based on comparison of within group variance or how spread out the data is within a category versus between group variance or how different the categories are from one another. So when we say within group variance, it talks about how spread out or how different the data is inside the group. Sagot diri sa within group variance is unsa kalahian ang data nga nasa sulod sa isa ka group. So, imo ra siyang tanawon kung unsa kalahian isa ra ka group nga basihan. While diri naman sa between group variance is unsa kalahi ang data nga sa ani nga group from the other group. So, kumbaga comparing one versus another. If the between group variance is large enough that there is little or no overlap between groups, then your statistical test will reflect that by showing a low p-value. This means it is unlikely that the difference between these groups came out by chance. Alternatively, if there is a high within group variance and low between group variance, then your statistical test will reflect with a high p-value. This means it is likely that any difference you measure between groups is due to chance. Itaas ko nga ang difference between group variance and na siya gamay nga overlap, ang pasagot-an niya is the difference is significant and probably not by chance. But if there's a lot of within group variance and the groups look similar and the p-value will be high, that means any difference we see is likely due to chance. So we can explain this by understanding what p-value means. So now I'm going to explain what p-value means. Okay, so the p-value is a number that helps us decide if our result is significant or just happened by chance. So a low p-value, usually less than 0.05, means the difference or relationship we found in the data is real and not by chance. So kung mubo dahil sa 0.05 ang ato ang p-value na makuha gikan sa itong i-gather nga data, ang relationship or ang difference nga itong makita sa data, sa source sa data, is tinuod if dili siya nagpangitabo nga tungod sa chance or coincidence ra. But a high p-value or more than 0.05 means the difference we found might have happened by chance. It is not statistically significant. So, kung atuang p-value is ubos sa 0.05, ang atuang data or the difference and relationship we found is real or significant. But if taas naman siya sa 0.05, the significant that we found is the difference or the relationship that we found in our data might have happened by chance. So this explains the meaning of the p-value explains the definition over here. Sa atuang step 3. So, your choice of statistical test will be based on the type of variables and the level of measurement of your collected data. So, based on the type of data that you collected, you perform a one-tailed t-test to test whether men are in fact taller than women. This test gives you an estimate of the difference in average height between the two groups. A p-value showing how likely you are to see this difference if the null hypothesis of no difference. So your t-test shows an average of height of 175.4 for men and an average height of 161.7 cm for women, with an estimate of true difference ranging from 10.2 cm to infinity. The p-value is 0.002. Based on the data that we collected or we gathered here, we were going to perform a one-tailed test because we are going to compare one group to another. So, nana siya ay formula and I'll be solving. Pakita na ko sa inyo kung ano akong pag-solve sa p-value para makuha na to ang itong p-value which is the 0.072.
So, good day everyone. So, my name is Ayan Grace Incabo, and today I will be discussing all about step 4. So, step 4, decide whether to reject or fail to reject your null hypothesis. So, based on the outcome of your statistical test, you will have to decide whether to reject or to fail your null hypothesis. So, in most cases, you will use the p-value generated by your statistical test to guide your decision. And in most common cases, you predetermine level of significance for rejecting the null hypothesis. So will be 0.05. That is when there is a less than 5% chance that you would see this result of the null hypothesis for true. So after di mo ma-finish ang imong statistical test, so you need to decide if ang imong null hypothesis is kanang difference ba or not, may difference or not. So sa step 5, so present your findings. So the result of hypothesis testing will be presented in the results and discussion section of your research paper, dissertations, or thesis. So in the results section, you should give a brief summary only of the results of your statistical test. So for example, the estimated difference between groups, means, and associated p-value. So in the discussion, you can discuss whether your initial hypothesis was supported by your results or not. So after mo maka-decide sa step 4, sa step 5 naman, i-explain mo ang result clearly on your or in your report paper. So, syempre sa present your findings naman pa, so dapat ang result dapat brief summary lang, and then explain if your hypothesis was supported or not. So in our comparison of men height between men and women, we found an average difference of 13.7 cm and a p-value of 0.02. So therefore, we can reject the null hypothesis that men are not taller than women and conclude that there is likely a difference in height between men and women. So, diri is ang decision na mo is amuang i-reject ang null hypothesis because ang p-value niya is 0.02 raman. So, dapat makalapaw man siya og 5% or 0.05 para basta kay ang step 4 mag-decide na kadira if imuhabang i-reject ang imong null hypothesis or dili. And then sa step 5, dira na naman i-present ang imong testing if kanang reject ba siya or dili. And then brief summary lang. And then so maar na siya, thank you.
Let's discuss the type of errors. So what is the type 1 error? A type 1 error, sometimes called a type 1 error, is the incorrect rejection of a true null hypothesis. The alpha symbol A is usually used to denote a type 1 error. An A or alpha of 0.5 indicates that you are willing to accept a 5% chance that you are wrong when you reject the null hypothesis. To lower this risk, you must be use a lower value for A, which is lower of 0.5. Example of that is 0.01. However, using a lower value for alpha means that you will be less likely to detect a true difference if one really exists. Meaning, a type 1 error occurs when you reject the null hypothesis or HO when it is actually true, This means you are concluding that there is a statistically significant or relationship when in reality there is no effect in the population. Again, in type 1 error, you are concluding that it is statistically significant effect or relationship, but in reality there is no effect in the population. So I'll give you some example for you to understand. And for example is in medical testing. So imagine a new diagnostic test for a rare disease. So if the test produces a type 1 error, it means the test indicates that a person has the disease when they actually do not. So this can lead to unnecessary anxiety, further invasive testing, and potentially harmful treatments. And also in criminal justice. So a court convicts an innocent person of a crime. The null hypothesis is that a person is innocent. So a type 1 error means rejecting the null hypothesis and wrongly convicting them. And other example is in marketing. A company launches a new advertising campaign believing it will increase sales. However, the campaign has no effect. So, if the company made a type 1 error, it wrongly conclude that the campaign is effective, continuing to invest in it when it provides no benefit. So, controlling a type 1 error. So, the probability of making a type 1 error is denoted by A or alpha. So, also known as the significance level. So, also known as the significance level. So, researchers typically set a 0.05, meaning there is a risk of 5% incorrectly rejecting a true null hypothesis. So, lowering from 0.5, example is 0.01, reduces the risk of a type 1 error but increases the risk of type 2 errors. So, next I'll explain what is the type 2 errors. So, type 2 error. A type 2 error, sometimes called a type 2 error, is the failure to reject a false null hypothesis. So, the probability of a type 2 error is denoted by the beta symbol or B. Type 2 error is a statistical term used within the context of hypothesis testing that describe the error that occurs when one accepts a null hypothesis that is actually false. So the errors reject the alternative hypothesis even though it does not occur due to the chance. So a type 2 error fails to reject or accept the null hypothesis, although the alternative hypothesis is the true state of nature. So meaning, a type 2 error occurs when you fail to reject the null hypothesis or HO when it is actually false. So this means you are concluding that there is no statistically significant or relationship, but in reality, there is an effect in the population. Again, type 2 error is you are concluding that there is no statistically significant effect or relationship, but in reality there's an effect in the population. Kaya na in the type 1 error, we are concluding that there is a statistically significant effect, but in reality there is no effect. But here in type 2 error, we are concluding that there is no statistically significant, but in reality there is an effect in the population. So for example, in medical testing, so using the same disease diagnostic test, a type 2 error occurs when the test indicates a person does not have the disease when they actually do. So this can be extremely dangerous because the person will not receive the necessary treatments, allowing the disease to progress. And other example is in engineering. So, an engineer fails to detect a flaw in a bridge design. So, the null hypothesis is that the design is safe. But because the engineer commits a type 2 error, they incorrectly conclude that bridge is safe when it is not. And other example is in the drug development. So, a pharmaceutical company tests a new drug that is actually effective, but the clinical trial traits to show a statistically significant benefit. So they conclude that that the drug is not effective and abandon its development. So missing out on potentially life a saving treatment. So controlling a type 2 error. So the probability of making a type 2 error is denoted by uh, beta. So the power of a statistical test is when represent the probability of correctly rejecting a false or null hypothesis. So researchers aim for high power, or typically 0.8 or higher, to minimize the rest of the type 2 errors. So power is influenced by sample size, the effective size, and the alpha level. So larger sample sizes and larger effects increase power. So why is it type 2 error and type 1 error important? So the importance of type 2 error is by understanding type 1 and type 2 error systems from their potential consequences and the trade-offs involved in minimizing them. First is sound decision making. So recognizing for the potential for these errors allows for more informed decision making. So based on statistical findings, so it prompts critical evaluation for the risk associated with each type of error in the context of the research. And second one is research allocation. So the understanding of errors types is a vital in making decisions about the allocation of resources. So for example, in the drug development, understanding the chance of a type 1 is versus type 2 errors helps with the decision to pursue the drug or abandon it. And the third one is reproducibility and reliability. So the scientific community relies on findings that are responsible or that are reproducible. So by understanding and minimizing the risk of these errors, reproducibility and trust can be fostered. And the fourth is ethical consideration. So in many fields such as medicine, ethics play a major role in type 1 and type 2 error. So convicting the innocent and not giving medicine to the ill are very bad. So in conclusion, a strong understanding of these errors allow you to proceed correctly through a research.